In this video, we're going to introduce the number e and the natural log. They go together quite a lot. The number e, I say not letter e, the number e, it is in fact a number. We'll use it a lot in maths, you'll see it a lot. You'll often see it with a power above it, e to the power of x. And the natural log is just the log of e. So log to the base e. Think of log to the base 2, log to the base 7, log to the base 9. There is a number e, log to the base e, and it comes up so often, it's so famous, we actually just write ln. It's just a shortened version of it, that's it. I already mentioned in the last video that log to the base 10 is so famous that we just write log a lot of the times. I don't particularly like that. I actually mostly write 10 in because computer science also do the same thing. So it's a little confusing. They can actually confuse us a bit. I'll often just write these. I don't think these are that special. And the reason for that is different numbers are special to different people. So we often get numbers with powers, especially we're going through the coronavirus at the moment. I'm in lockdown right now because of something being exponential. That's when something is to the power, so 3 to the power of x, where x changes every day. Maybe how many cases of coronavirus there is. Day 1, there's 3. Day 2, there's 9. Day 3, there's 27. Day 4, there's 81. It gets bigger and bigger and bigger. Or maybe the base number is 2. This would be better for coronavirus. Maybe the base number is 9. That would be a lot worse. That would get a lot bigger, a lot quicker. But now that we've learned, now that we have learned how to do logarithmics, we can actually change this base number. We can pick whatever number we like. We can choose to be different numbers. I'll leave x off for a moment. I'd like to show you just an exact example. Maybe I'll write them here and I'll do the work over here. Let's say 2 to the power of 3. We could write that as 10 to the power of something. I'll leave a big box here because I'll work out what the number is. Or we could write e to the power of something. And again, I'll talk about what e is more in a moment. But I'd just like to point out, we don't have to use, if we don't like 2's, we could use 10's. If we don't like 10's, we can use e's. It will really just change the number up here. And in the example where there was an x, it will change it so it's maybe 2x or a half x or 7.4 x's. I'll do x at the end of the video. I just like why I picked these 3. These are 3 famous ones. Computers think this is the best base because they love the world 2, 4, 8, 16, 32. That's how they think. Humans, well not all humans, but our society, we like 10's because it's something we've used for the last long time, the metric system. 10, 100, 1000, 10,000, 100,000. That's not natural. It's just something we like to use. So we like things that go up in 10's. And they're easy for us to do. Our number system is based on 10's, so it's very easy for us to do. But mathematicians, we like e. E is a brilliant number for doing exponentials. I don't really want to go into too much detail why. I'll just briefly describe why it's important. In maths, in general, in life in fact, like I said, things exponentially grow a lot. Populations grow of viruses, of people. Things dwindle, things grow in this shape, this exponential curve. And this could be 2 to the power of x, 10 to the power of x. But e to the power of x works out really nicely for us. Or e to the power of anything here. Well, e to the power of x works out especially nicely. Its curve, its slope here at 1, its slope at 1. At 1, the function itself is equal to e, but its slope is also equal to e. That means its derivative, which you're not expected to know yet, its derivative, its antiderivative, is the same as itself. It makes these functions really easy to deal with, really easy to manipulate. And for that reason, in maths, we love changing everything into e. We think it's the best number to use as a base. If we ever have powers, we like to change it into e. I'll rub this out, it's not important for now. Now, not when it's just a simple number. In this case, 2 would be the best because it comes out nice and evenly. But when it's an x, which I'll do at the end, like I said. So let me just change these quickly. 2 to the power of 3 is equal to 10 to the power of something. Well, if we don't know something, we'll put an x in for it. Let's just solve x then. I can use P, A, any letter you want. I'm just going to solve for this. So how do I solve for x? I need to destroy the 10. So we get the log to the base 10 of both sides. Equals log to the base 10 destroys the 10 and leaves just the x. Rules of logs, this 3 can come down and multiply. That's the power rule. Equals x. That's what x is equal to. We can put this number in on a calculator. Let's go ahead and do that. It's not going to be a pretty number. In fact, I would rather leave it like this. But just to show you, it's not a load of letters. It is a number. It is 3 log 2. I can use log because its calculator uses log so much it decides 10 is, instead of log 10, it just says log, is what I'm saying there. I'm sorry, this number is equal to 0.903. That's the 3 decimal places. So that's this number here. 0.903. So instead of base 2, I could write base 10. Like it's something I could do. Instead of base 10, I could write e. Let me do this one a little faster. We have log to the base e. 2 to the power of 3 is equal to x. Remember what I said though. This is where I'm going to introduce the natural log more. We write this so often. This happens so much. We're going to save ourselves time. Don't worry, you can write this if you want. Everybody will know what you mean. But just to save yourself a few little strokes of a pen, I'm going to write ln. That's it. That's the only trick there. It's no trick really. It's just laziness in mathematicians. And once again, this 3 can be wrote out front. This works just like every other log, no different, just because it looks a little different. Equals x, and this is, let me check what number it is. The calculator has its own button for this. Again, it happens so often. It has its own button. This number is 2.079. Again, the 3 decimal places. 2.079. So instead of dealing with base 2 or base 10, we like just dealing with base e. In this case, it would be silly because these numbers aren't great. The 2 would be perfect. But sometimes it might be a case like this. It might be, let's go 2 to the power of x. Now, I might want to write that as e to the power of something. I'm going to need a different letter now because I've just used x again. Let's go with p. A. Let's go with p. So let's solve for p. Let's get the natural log of both sides. Natural log of 2x is equal p. X natural log of 2 is equal p. So instead of writing 2 to the power of x, I could write 2 to the power of x is the same as writing e to the power of x natural log 2. That's it. This is just a lot easier for us to deal with in mathematics than this number here. This is simply just a number multiplied by x, something we learn to deal with very easily in differentiation. Anyway, that's it. You're going to start seeing this letter e. You're going to see e to the power of things, e to the power of 7, e to the power of 2x, e to the power of x squared plus 4. You're going to start seeing a lot of e's. Don't get afraid of it. It's just like seeing 2 to the power of. It's just like seeing 10 to the power of. If you want to do a lot of stupid work and put it back into 10, go ahead, but I wouldn't advise it. We're just going to end up using it a lot. You're also going to start seeing a lot of natural logs. I won't write out a few of them. Lateral log of things. Again, that just means log to the base 2.7. Oh, I never wrote what this number is. 2.7. I think it's 1.8. Maybe it's 2. I'm not sure. I'd have to look it up. It's 2.7 something. Just like pi, it doesn't have a nice fraction. It's not a rational number. It's an irrational number. Okay, that's it. I just wanted to introduce these two concepts. Thanks for watching. Next video we will do some natural log or equation equations involving natural logs, maybe where we have to solve them using natural logs, or solve ones with natural logs in it. Sorry, not just natural logs, all logs, but there will be some natural logs. Until then, have a good one and goodbye.